All right, join me for the next Math on the Spot. You're going to need scratch paper, so if you don't have some, go ahead and get it now so you can follow along. All right, let's get started.
You know, visualizing data is one of the most valuable ways of actually seeing things within the data. This reminds me of a great story about Sunny, who was actually making a claim about some interesting data involving, of all things, bobcats. Let's check it out for ourselves and see what we think about Sunny's thought. Let's check it out. Okay, so this histogram here shows the weights of several bobcats rounded to the nearest pound. Now, Sunny says that the graph might have a different shape if it were redrawn as a bar graph with one bar for each number of pounds. Is Sunny's statement sensible, or what do we think? Well, let's take a look and see. Well, the first thing that I notice is that this is indeed a histogram, in that what we see is we see these bars representing different intervals of weights in this case, and on the y-axis we see the number of bobcats that actually have these various weights. So for example, of bobcats that weigh 15 to 17 pounds, we see that in this particular data set there were 4 such bobcats. So there were 4 bobcats that weighed between 15 and 17 pounds. Interesting. You can also just read a lot just from the graph looking at this, right? For example, you could see that in fact the peak is somewhere between 18 and 20 pounds in terms of the most popular weights, right? 8 bobcats weigh in that something in that range. And notice that in fact the popularity seems to be increasing to the peak as in fact the weights increase. But then after 20 pounds, then in fact we see a drop in population as in fact the weights get larger and larger. That is to say that as the weights go from 20 pounds and continue to go up, the number of bobcats of those weights begin to shrink. So we see a lot just from the picture. But what about Sunny's claim that the graph would look different if in fact it were redrawn as a bar graph with one bar for each number of pounds? Well, the answer is that in fact there might be some gaps that we would see, and in fact we would see maybe different peaks along the way if in fact we had the representation for every single pound. For example, there are only 3 bobcats that are in this region, right? That weigh 12, 13, or 14 pounds. So would they each be 112, 113, and 114? Or would in fact, is it possible that in fact what we'd see is maybe 2 of them in fact weigh, let's say, 12, and then one of them weighs 13 pounds, and then one weighs nothing. So in fact, this one bar would actually potentially be a lot different, because maybe 1 weighed 12, and maybe 2 weighed 13, and maybe 0 weighed 14, in which case the graph would look much different. In fact, I know I really don't want to write on this, but okay, you know what? I get so excited sometimes I have to. So maybe it would look like this. So 1, I can do it. 1 weighed 12 pounds, and maybe 2 weighed 13 pounds, and then 0 weighed 14 pounds. Well, you see how it would look then? Then it would look something like this. 12 pounds, 1 bobcat weighed, 2 bobcats weighed 13 pounds, and 0 bobcats weighed 14 pounds. Now you notice that still, how many bobcats are represented? Well, 1 plus 2, 3, so it's still 3 bobcats, but now you see the picture would look very much different. It might be much more jaggedy, for example. So I think she's absolutely right, that if we actually had, instead of intervals, individual 1-pound increments, then this picture would look a lot more bumpy. And it would give us maybe some more information. The question, of course, really is, do we need that much information? This really gives us the trend, as we analyzed earlier, and so in fact that might be just enough for what we're looking for. If we wanted to know something individual by individual in terms of weights, pound by pound, then maybe this picture would be a little more accurate. But this picture might be too complicated for the kind of seeing the trend that we want, this is enough to see the trend. And so I'm going to take this, by the way, and just get rid of it and say, bye. Whoops. I don't want to do that. I want to say, get rid of that. Whoop. No, I don't want to do that. Oh, I'm so silly. Look at me go. I don't even know what I'm doing. Maybe I can't even do this. I don't know. In fact, I'll try one more time, but I think it's not going to work, actually. Now I see. Yeah, you know what? I give up. So the point is, don't look at that. There we go. There's the graph that actually makes the most sense. This histogram actually represents kind of a sense of how the data is moving. If you want a pound-by-pound measure, it's going to be a lot more jagged. So in fact, Sunny is absolutely correct. Well, Sunny's correct, and so are we. The point is that in studying data, we have to figure out appropriate intervals in which to measure our data so that the picture we get or the distribution we start to look at or the thing that we're studying actually has meaning. Once it has meaning, we can stop right there. To dig any deeper and deeper and deeper might give us more and more information, but it might not give us any more insight into the situation at hand. Picking the right interval sizes is a very important thing to do in statistics, and this little story that you and I thought about together really illustrates that. Have fun thinking about the intervals in your life. I'll see you soon.
Thanks for watching. I'll see you on the next one.